They can't keep getting away with it, okay? They are not allowed to keep getting away with it. What I'm talking about is this trend in the cybersecurity industry where it seems as though router manufacturers are unable to do anything correctly. And maybe you work at a router manufacturer, maybe there's something that I'm missing, but we're talking today about two CVEs and a line of Acer routers, and not ones from 10 years ago, ones that are new, where the bugs in question are baffling.
You can't keep getting away with it!
Now, this new footage, this new area, this new POV we're seeing here is a commentary on the previous video that I made where I ranted at my Wildwood apartment when I was on vacation. Y'all seem to like that, so I'm going to keep doing this a little bit. I'm going to make it a little more natural. We'll go to the computer here in a second. But this video is going to highlight a disturbing trend in the IoT industry that I'm hoping we figure out what the fuck is going on in the near future. Now, this studio doesn't pay for itself. This camera, that light, that mic doesn't pay for itself. So let's check out today's sponsor.
Because if you've ever wrestled with your company's SASE solution, this one really matters. Here's the thing. The way companies secure traffic today is built for an internet that no longer exists. Traditional SASE solutions drag all the traffic through a distant cloud endpoint, decrypt it, inspect it, and then re-encrypt it. This adds latency to the process, and also with modern encryption technologies and certificate pinning, a lot of the traffic is not even able to be inspected this way. The visibility gap in your network is growing every day. Now, Island flips this idea on its head with their technology called Perfect Packet Architecture. Instead of backhauling everything off to a distant cloud, Island decides where the packet should be processed first, with 90% of the traffic most of the time being handled locally on the device. And when traffic genuinely needs network inspection, Island pushes that data into their global network, which has redundant failovers built on Google Cloud Platform, AWS, and Azure. Internet backhaul becomes the fallback, not the default. And the reason this design matters right now is AI. More and more AI providers are becoming resistant to network inspection. Island governs all of this locally at the point of intent, with full audit trails about where the data goes. Guys, you know the rule. The best way to help the channel out is to go check out the sponsor, go see if Island is a better fit for your network stack, and next time you hear SASE, give Island a shot.
Acer working to patch max severity 0 days in Wave 7 routers. Wave 7 routers looking like this, some marketing documentation, very good, very cool pictures. I like it. Now, let me be very clear, guys. When I'm making these videos, I am aware that it's very hard to have bug-free code. It's literally impossible most of the time to write code that doesn't have vulnerabilities. Okay, so when a company has a security blunder, I'm not throwing rocks oh, fuck you for making mistakes. It's when the overall architecture of the mistake is so catastrophic, I begin to question the sanity of the company, if that makes sense. Okay, so according to a Friday security advisory, the two security flaws were reported by a security researcher, Garrigo Pop, I believe. I'm sorry if you're watching this and that's the incorrect pronunciation. The Wave 7 router is running this version, so this 101 something 55. First 0 day is a broken access control vulnerability. Again, so when I see the CVEs, I'm like, oh, maybe it's some complex use after free that leads to a vtable corruption that allows an arbitrary read or write that allows. Okay, so if you click on the CVE and we go to the Acer to dispatch, the report from Acer about this vulnerability, let's read what it says. Broken access control. The Acer CGI log file in the device firmware is accessible without authentication via the web interface. I'm gonna go take a break real quick. I'm gonna go take a breather. Give me a sec. Okay, and then it continues to get better. The file contains clear text login credentials for web and telnet, leading to unauthorized system access. And yes, as a shock to nobody, this is a critical 10.0 CVSS, okay? How the frig this is even possible is bonkers to me. There are so many things that are incorrect here that I need to dive a little deeper into this. The ability for there to be a log file on a device without authentication is generally not a huge deal, okay? Maybe the log file is strictly just uptime, downtime, right? There could be an argument that the uptime, downtime maybe is leaking sensitive details about when your house is powered on or when you are or not home, stuff like that. But generally, logs may not necessarily need to be behind an auth wall. This is, I honestly don't even know how this is possible. This file contains clear text login credentials for web and telnet, leading to unauthorized system access. How is that happening? Now, honestly, one way that I could see this occurring as someone that's done a little bit of vuln research and software dev on embedded devices, a lot of these devices ship on accident with like the debug builds from the factory or from the developer that like has a lot of really kind of like sensitive log information, right? From the developers, right? Just to test to see if their code is working. A lot of the times you'll see in a function, maybe it's like in the login function for the web interface, they'll say if user is logging in with username X and password X, they'll put that in like a printf function, but one that the company maintains, like Acer printf, for example. It's entirely possible that like a version of Acer printf that some other team is working on is also logging all of that data to acercgi.log. So like this log file may have been benign, but because like a debug entry for their firmware got pushed to the wild, now it's just logging all the credentials for web and telnet into the log file, which is just like, again, I'm not trying to throw stones, but it's like, guys, how did that miss security review? That's insane. If they're doing security review, I have no idea. The next bug is funny, I guess, if you want to call it funny in like a different way, like kind of like a cosmic sort of way. Yes, the plankton meme. A hard-coded cryptography key. So the upload.cgi binary responsible for processing device backups contains a hard-coded AES encryption key. This allows an attacker to decrypt, modify, and this is where it gets crazy, re-encrypt system backups, facilitating persistent backdoor injection. So again, I haven't actually pulled down one of these binaries. I haven't looked at the actual contents of the backup. What I'm reading from this is basically the upload.cgi binary is a way for you to, let's say you have an Acer router and you want to back up like the config or like maybe something on the device. So that's like very like, you don't want it to go away. So you back up the device, it gets encrypted so that the backup, which I presume contains your now plain text credentials from acercgi.log, it's encrypted, which is good. Problem is every device has the same AES key. So what this means is you can take a backup from your Acer router, use that hard-coded AES key, decrypt it, put a piece of malware into that upload.cgi file, re-encrypt it with the AES key. AES, which I'm assuming they're using like CBC or EBC, the different modes of AES, neither of those modes are authentication, right? I think like AES GCM does authentication as it like within the cryptography. But because it's not authenticated, you can then take that now re-encrypted upload file and push it to upload.cgi, allowing you to push your malware that you wrote, that you took the backup from your router into someone else's router. Oh, by the way, you can use the plain text password that you found in acercgi.log to do exactly this whole thing. Now, again, I'm really not trying to throw shit in any company. I know like companies that are big enough, it's hard to coordinate across teams what security boundaries do and do not exist in certain locations. I know a lot of you may be being like, oh, it's like a 3-letter agency backdoor. First of all, these are made in Taiwan, so I don't know what that means. Second, bug doors, right? The idea that a vulnerability is intentionally left by a company on behalf of the company, the government, or whatever, are so hard to prove that like it's not even worth considering, because I don't know how you would go about proving that. It could literally just be like the bug exists in the code and that's kind of like where it ends. And that being said, I want to highlight that like this is not just Acer. This is not just Taiwanese router companies. This is an issue with all routers, by the way, and some of them enterprise grade. This is a graph that shows the number of CVEs published per year. I want to highlight a few kind of different parts of this graph. First of all, on the left here, this is when like I think consumer grade vulnerability research, the ability to like do VR with things like, well, Guidry came out in 2019, but the ability for people to do VR at their houses for the world of VR to explode kind of happened in like the 2013, 2016 era. So I would acknowledge that as the reason for this blow up. And you can see there is like a descending kind of line here where I think up until like 2020, if you opened a piece of router firmware, most of the binaries didn't have like modern exploitation mitigations like ASLR, DEP, basic things that now come as a function of the normal features of a kernel or your build chain. So it is trending positively, but it's important to highlight that these companies that are not all the companies, also ones like Fortinet, also ones like Ubiquiti, and Ubiquiti actually a little bit less. Either way, these companies, like there have just been so many router CVEs. This is a trend in the industry that needs to get better because guys, like these devices are the front door to your home network. Now, one easy way to do this is for today's video. Just kidding. One easy way to make your network a little safer, disable remote authentication. Like I think some of these may ship with remote auth on by default. Turn that shit off. All these bugs, by the way, are bugs in the front end, if you will, like the web interface of the router. And so as long as you can't access the web interface from the WAN, you're probably fine. Where it gets a little more hairy is like if you get cross-site scripted or there's some kind of like injection of content into the site you're viewing via like a browser exploit, they then can use the ability to inject JavaScript into your browser to like potentially exploit the web interface of these things. So like it's still dangerous regardless of kind of your configuration. So one easy win is like just disable the web interface. Anyway, guys, that's it for now. Thanks for watching. I appreciate it. If you like this video, hit that sub button. Maybe you're new here. Maybe you're not. I hope you're new. Maybe, I don't know. And then go check this video out that I think you will enjoy just as much. This video about something similar that is kind of wild. We'll see you over there. Goodbye. How did that miss? What?